In this video, I'm going to look at chemical cells and batteries. So we'll start with some essentials. Metals form positive ions when they react, and they do that by losing electrons. So in the example of zinc, zinc forms the zinc 2 plus ion by giving away 2 electrons. Copper does something very similar, forms a Cu2 plus ion, again by losing or giving away 2 electrons. So the generic equation for that, for any metal, so metal forms the ion and it loses the number of electrons relevant to the charge. I'm writing these half equations as reversible processes, and you'll see why when we come on to the next slide. Reactive metals form ions more readily than less reactive metals, or you could think about it as the more reactive a metal, the more easily it loses its electrons. And chemical cells are made by combining two different metals and an electrically conductive substance which we call an electrolyte. And finally, for this slide, batteries are just two or more cells connected in series to give a greater voltage. So we're going to see all of that in action now with the example of the zinc copper cell. So what's going to happen if we make this cell? So let's get the diagram on the screen first of all. So we've got a zinc electrode and a copper electrode, and they're dipping into the electrolyte, and the classic example of an electrolyte is aqueous sodium chloride. So for the purpose of this slide, I'm going to tell you that zinc is more reactive than copper, so that means it's going to give away its electrons more readily than copper. So the half equation for the zinc electrode is going to run in this direction, so it's going to lose its electrons and give us that. So the electrons are going to travel around the external circuit, so these are just wires connected to a voltmeter, and they're going to end up at the copper electrode. Now copper can't accept electrons, it's the copper 2 plus ions that can do that, so its half equation runs in reverse, and that's why I've written them as reversible processes, because it all depends on the reactivity of the two metals which way the half equation is going to run. So the most reactive one runs this way, losing electrons. The least reactive one gains electrons. So to get the overall cell reaction, all we need to do is add those two half equations together. So we get that, and you can see we've got the same number of electrons left and right of the arrow, so they're going to cancel out, and they're going to leave us with that. And hopefully you can see that that's a redox reaction because the zinc has been oxidized, it's losing electrons, and the copper 2 plus has been reduced, it's gaining electrons. So I'm sure from your physics you know that electrons flow from negative to positive, so that means that the zinc electrode is the negative electrode and the copper electrode is the positive electrode. So we'll just name these electrodes now, and need to do a little bit of explaining here because it's going to contradict something that you've seen already if you've studied electrolysis. So in electrolysis, the positive electrode is the anode and the negative electrode is the cathode. But in this type of cell, it's the other way around. So the negative electrode is the anode and the positive electrode is the cathode. And if you think about it, this type of cell is producing electricity, whereas in an electrolysis cell, you're adding electricity or supplying electricity to the cell, so it's effectively doing the opposite thing. So the electrodes are the other way around in terms of their names. So it's important things to remember now for each electrode. So oxidation, loss of electrons, always takes place at the anode, that's the negative electrode, and it's where the most reactive metal is. And the way I remember that is the word oxana. So for the other electrode, the cathode, reduction always takes place at the cathode. That's the positive electrode in this type of cell. It's the least reactive metal is the cathode. And an easier way to remember that is red cat, reduction at the cathode. So why do some batteries run out? Well, if we think about this cell would actually run out eventually, and it's because the overall reaction, the cell reaction is not reversible. So ultimately, that zinc electrode is going to disintegrate because the zinc atoms in the metal electrode are turning into zinc 2 plus ions, and the copper ions are turning into copper atoms. So you'd actually see this electrode actually growing in size because copper's being deposited on the side of it. So obviously, rechargeable batteries like the one in your phone, they are reversible processes. So when you plug your phone into the charger, into the wall, then you're reversing its overall cell reaction and you're just making the reactants back. What if you have different numbers of electrons in your half equations? So we'll look at an example of that now. So zinc and silver cell would have that. So we need to know zinc is more reactive than silver. I'm sure you knew that sort of from basic reactivity series. So there's the two half equations. Remember, the most reactive one runs as an oxidation process. The least reactive one runs as a reduction process. And you can see that the silver half equation's only got one electron in it. So all we need to do is double this half equation before we add it to that one. So that's going to give us that. So you can see we've now got 2 electrons on each side of the arrow. They can cancel and leave us with this as our overall redox reaction. Why do some batteries produce a higher voltage than others? Well, that all depends on the difference in the reactivity between the two metals. Obviously, the greater the difference in reactivity, the higher the voltage is going to be in your cell. So we'll finish with this exam style question. So a student set up a cell a bit like the one that we saw on the second slide. They've got a magnesium electrode and they're varying the metal for electrode A. And you can see it's dipping into sodium chloride, aqueous sodium chloride for the electrolyte. So we've got zinc, copper, cobalt and silver, and the voltages produced for each electrode. Magnesium is the most reactive of all the metals used by the student. Magnesium, zinc, copper and cobalt all form 2 plus ions, and silver forms the 1 plus ion. So if you want to have a look at the 4 questions down the left hand side there, pause the video and then play on for the answers. So which metal is the least reactive? It's going to be the silver because it's given us the greatest voltage. So therefore there must be the greatest difference in reactivity between the magnesium and the silver. What's the order of reactivity of the 5 metals? Remember, magnesium was the most reactive metal in the cell. So we're looking at the voltages. The smaller the voltage, the closer they are in reactivity to the magnesium. So it's going to be magnesium, then zinc, then cobalt, then copper, then silver. Third one, chromium between copper and zinc in reactivity. Predict the voltage when chromium's used in the cell with magnesium. So it's basically going to be somewhere in between this 1.61 and 2.10 volts. And finally, write the half equation for the reaction taking place at the positive electrode of that cell. Well, the positive electrode is going to be the cobalt electrode because it's the least reactive of the two metals, and reduction always takes place at the positive electrode, so it's going to be that one there.